Good morning, afternoon, or evening, whatever time of day it is when you're watching this, and welcome to another set of video notes. This is going to be the first set of notes in a series all about meteorology. Weather and climate is pretty much our last unit. We're going to be talking about various weather and climate type things for the rest of the year, for the entire last 9 weeks, and this is kind of the beginning of that. So, what is meteorology? It is the study of weather. It affects each and every aspect of all of our lives. I decided to take my dog for a walk later on in the evening when it was warmer outside, and I had to plan my when I would eat dinner around that. So even just the small aspects of our lives are determined by meteorology and the weather. And the US has the greatest variety of weather in any country in the world. It could be a tornado here and snowing in Colorado and a hurricane in North Carolina all at once. We have the most variety out of any country. Meteorologists study a lot of different things in their study of weather: temperature, moisture level, Earth's heat budget, which we'll talk about next week, wind patterns, precipitation, pressure changes, which is going to be really important and kind of this is what determines a lot of things. And we will talk about that more next week as well. Seasonal weather changes, air quality indexes, like right now there's a lot of pollen out, so the pollen index is high. Conditions that might lead to drought and severe weather. There are two main things that come to mind when people think about meteorology: weather and climate. Those are two different things, and you've probably learned about this before. Weather is more short term, it's what's happening daily or hourly, it is constantly changing. You know how some days it is raining 1 minute and the next minute it's sunny and 80 degrees. That's talking about the weather. And this affects small geographic areas. It might even be as far as your neighborhood. One time it was sleeting on my street, and two streets over, there was nothing. There was no precipitation. It could be communities, entire cities, or the county. Maybe Collin County is having a torrential downpour, and in Denton County, it's perfectly sunny. Climate, on the other hand, is much more long term. It covers decades or centuries. It covers large geographic areas like entire regions or countries. The entire coastline of a country is what's covered by climate, and it's more generalized. It is a composite of weather, so it is all of the weather kind of smashed together into one, and it can change with altitude, with latitude. It's more general and vague. The first thing we need to know about in order to really study meteorology is going to be the atmosphere of Earth. So maybe some of this is review, maybe this is brand new to you. Either way, here's what you need to know about Earth's atmosphere. What is it, first of all? It is an envelope of gases that surrounds the Earth. It has a pretty constant mixture. There are going to be some slight variations, but for the most part, the atmosphere is constant in what the mixture of gases is. And it serves two main purposes for life on Earth. One, it acts as a blanket, and two, it acts as a shield. It acts as a blanket, keeping in all of the helpful things we need, like oxygen to breathe, and it acts as a shield, blocking harmful energy and harmful particles like UV rays from the sun that would hurt us. And Earth is not the only planet with an atmosphere. In our solar system, Mercury is the only planet that doesn't have an atmosphere. So Venus, Mars, Jupiter, Saturn, Uranus, Neptune, all of them have atmospheres. Titan is a moon in our solar system that has an atmosphere kind of similar to Earth's. Mars doesn't seem like it, but it's got a very thin atmosphere. Um, Lots of bodies in the solar system have atmospheres. So, what is that constant mixture of gases? Our atmosphere is 98% nitrogen, or 98, 78% nitrogen. Our atmosphere is 78% nitrogen. It is 21% oxygen and about zero point 0.9, or some will say 1% argon. So more than three-fourths of our atmosphere is nitrogen. About a fifth of the atmosphere is oxygen. about 1% is argon, and everything else makes up the tiny amount left over from that. Carbon dioxide is about 0.04. Down here it says 0.03, but this is a kind of out of date graphic. The most recent readings put it at 0.04%, which doesn't sound like a lot, but we're going to talk more about that in a minute. And there are some other kind of variable components. This is what I meant when I said it's pretty constant. The amount of water vapor changes. That's kind of like how humid it is, which we're going to talk about later. Humidity. So water vapor can change. Dust particles or any solid particles that are suspended in the air. There's probably going to be more of that, like after a volcanic eruption when there are more pyroclastics. And ozone, which is O3, which can be formed both naturally and from pollution. The amount of ozone in the atmosphere has changed over time. So those three components can vary sometimes. Some gases change. Carbon dioxide, I said, was 0.04%. That pie chart on the last side had it at 0.03%. 0.04 is the same as saying carbon dioxide is in the air with an amount of 400 parts per million. So if you had 1 million pennies and each penny was part of the atmosphere, then 400 of those pennies would be carbon dioxide, which doesn't sound like a lot, but it's kind of more complicated than that because carbon dioxide has been increasing in our atmosphere, mostly because of industry in emerging countries. Carbon dioxide is increasing. So you can see since 1960, where we've been tracking this really well, it has just been going up. And this chart even stops, only gets to 370 in the year 2000, but we've climbed more to 400 parts per million now in the year 2020. Ozone, another one of those variable things. 3 important things to know about ozone. First, it's crucial. We need it. It absorbs ultraviolet rays from the sun, which would harm us and burn us far more than the UV rays that give you a sunburn. UV wavelengths, if not absorbed by the ozone layer, can cause mutations and cancer in living organisms. So having ozone to prevent that from happening is a must. Ozone is actually toxic to breathe, but it's not found in very large quantities at the surface, so we're doing all right. It is mostly found in the stratosphere, and we're going to talk about where that is in just a second, but it's 10 to 50 kilometers high. And ozone needs the sun's rays to be formed. Most of the time, molecular oxygen is O2, so it's 2 oxygen atoms that are stuck together. When the sun's rays hit an O2 molecule, it will break it apart. So now you've got 2 oxygen atoms that are free. One of those oxygen atoms will run into another O2, and you end up with O3. So you need the sun's rays to break up an O2 so that you can get an O3, an ozone. The second thing to know about ozone is that it does not last forever. Contaminants in the air can destroy ozone, specifically CFCs, which are also chlorofluorocarbons. This was a really big deal in like the mid 2000s when aerosols were much more popular and aerosols were releasing chlorofluorocarbons into the atmosphere. We had a hole in the ozone layer for a little while, which was really dangerous, but that has, because ozone can continue to be formed, has actually shrunken. Chlorofluorocarbons, can break apart that O3 into O2 and a free oxygen atom. So chlorofluorocarbons will break down O3 in the stratosphere, and making sure that ozone remains relatively constant, we aren't losing any, is going to be important to make sure we don't have UV rays coming in and causing mutations and cancers. The third thing to know, and kind of a big one, is that ozone is toxic. It is really important up here in the stratosphere, but if it were found down near the surface, it would cause major health problems. It is toxic to breathe. It is a major component of air pollution, and automobiles, cars, and industry are kind of the biggest air polluters down at the ground level. Cars are the number one air polluter, and they release ozone in their exhaust, and ozone down at the ground level is dangerous and toxic. So I mentioned the stratosphere. Back on this slide, it mentioned the troposphere. Now we need to get into what are the layers of the atmosphere. A couple of key points about the atmosphere. For this class, we are always going to talk about going from the bottom up. So when I say the first layer, I'm talking about the first layer from the ground at the very bottom. The last layer is the layer closest to space. We're working from the bottom up. So as we move up through the atmosphere, the air becomes less dense. You're going to see what I kind of mean by that in the video I've got for you to watch next, or the movie for you to watch next. It also becomes colder. And I want you to take a second to look at this graph, because down here at the bottom, it is temperature. And this red line shows the temperature as you move through the layers of the atmosphere. So starting down at the bottom, it's average room temperature. When you move up through the air, it gets colder. So when you're climbing a mountain, it's freezing. Then it warms up a little bit in the stratosphere, jumps back down to being incredibly cold in the mesosphere. But then in the thermosphere and exosphere, it shoots up and we get to like 1,000 degrees Celsius. So how could it possibly be that the atmosphere is getting colder when this graph clearly shows that the temperature is going up? It's getting up to 1,000 degrees Celsius. The way that works, it relies on the fact that the air is becoming less dense. In scientific terms, temperature is a measure of how much energy the particles have. So if you think back to solid, liquid, and gas, solids, you had particles that aren't really moving, they have low energy, and they're kind of stuck right next to each other. Liquids, they can move around a little bit more, they've got more energy, more room to wiggle, and gas, they're all over the place. They've got high energy wiggling. That's why frozen water is solid and the hottest water is gas. So as you move up through the atmosphere, it becomes less dense. There aren't a lot of particles filling all of that space. So even though it's incredibly high energy, the particles are moving all over the place, there are barely any of them. If you dropped a single drop of boiling water on your hand, it would not burn your hand as much as if you dunked your entire hand into a pot of boiling water. So even though it's a high temperature because it is high energy, there's just not a lot. And so the amount of heat transfer that can occur is practically nothing. So we say space is cold and the atmosphere is getting colder as you move up, mostly because it is less dense. The particles have a higher energy, which gives them a higher temperature on this scale, but it is colder because it is less dense and there aren't enough particles to do anything about it, to feel that heat. And above 100 kilometers, the atmosphere is basically non-existent. There are some arguments within like astronomical communities about where the atmosphere ends, because as you move up, it just gets less and less dense and there are fewer and fewer particles, and there isn't really a clear line, like it stops here. So people will debate about what the last layer is, where the atmosphere stops, because it just kind of very slowly fades away. Most of what we care about is down at the bottom. 50% of all air is found under 6 kilometers, and 90% of all air is found under 20 kilometers. So most of the air is way down here at the bottom. All the rest, 10%, covers 500 plus kilometers. So not a lot of air up there. This is another really helpful graphic to show kind of what's going on at different layers. We've got the surface down at the bottom. I have that temperature curve again. Remember, even though it says increasing, that's talking more about the energy of the particles. Space is cold. If you've ever watched a space movie where somebody goes outside the spaceship and freezes, it's because space is essentially a vacuum. These particles, even though they are high energy, are too spread out to warm anything up. So down here in the troposphere, this is where you've got weather happening. This is where you've got planes flying, parachute jumps. The stratosphere is next. That's where the ozone layer is. That's where you might have supersonic or spy planes. Up in the mesosphere, that's where most meteors burn up. The thermosphere is where you get the polar lights, and you up higher in the thermosphere, that's where you have some spacecraft. And the exosphere, which some consider to be the last layer, is where you have satellites orbiting. So to go through that more in depth, the troposphere is the first layer. It is the one all the way at the bottom. Depending on where on the Earth you are, it's anywhere from 6 to 10 miles above the surface. It's typically between 17 and 52 degrees Celsius. 75% of the mass of the atmosphere is here. So most of the gas that makes up the atmosphere is in the troposphere. This is where most weather occurs. This is where most clouds are, most rain falls in the troposphere, and it's the layer we live in. Next, you have the stratosphere. It is the second layer. It comes after the troposphere. It is 6 to 10 miles thick. It is drier and much less dense. Remember, as we go up, it's going to continue to get less dense. This is where we have the helpful ozone layer. This one is not affecting the air we breathe. It would be toxic if we were up there, but we're not up there. So this is the one that is protecting us. And up here, you get the temperature dropping. The stratosphere is cold. This is where you have some weather balloons, a couple of clouds, some higher clouds, but most of the weather is going to be down here. A couple of like spy planes. The mesosphere comes next. It is the third layer. It is 53 miles up. Temperatures are down to negative 93 Celsius. Remember, 0 degrees Celsius is the freezing point of water. We say that this layer gets excited from ultraviolet rays, but we've got a feature called sprites. We have meteors burning up in the mesosphere. This is where some rockets get launched to. So the mesosphere is third. It comes after the stratosphere. Fourth, we have the thermosphere. This is, by most standards, the tallest layer, I suppose. It is 350 miles high. It is also sometimes called the ionosphere. It's ionized. This is where most energetic photons from the sun are absorbed, which gives us the aurora borealis, the northern or southern lights, and radio waves are reflected. It is the hottest layer. It's absorbing all of those energetic photons from the sun, giving more energy to the particles in the thermosphere, and temperatures can reach above 1,100 degrees Fahrenheit. But remember, there aren't as many particles the higher up you go. So it is really hot, but there's not a lot of particles for you to run into to transfer that heat to you. This is where the International Space Station orbits, in the thermosphere or the ionosphere. And lastly, we have the exosphere, which can be, by some standards, 10,000 kilometers thick or tall. This is where atoms and molecules are escaping into space. The atmosphere is gradually fading away. This is where most satellites orbit. And some people do not consider this to be part of the part of the atmosphere. Some people will just say troposphere, stratosphere, mesosphere, thermosphere, and be done. We're going to throw in the exosphere to just keep in mind that it is slowly fading away. But those are the layers of the atmosphere for you to be familiar with. You should be familiar with the fact that the amount of CO2 in the atmosphere is increasing, and we're going to talk much more about that later on in the year. And you should know about ozone and how it is both helpful and harmful. Up next, you're going to have a movie to watch about what happens to the human body in thinner air, for example, if you were climbing Mount Everest. And then there'll be a short open note quiz kind of thing about the layers of the atmosphere. As always, if you've got any questions, send me an email, and I hope you all are staying healthy and sane in your houses. Remember to take breaks and take time for yourself. Go do a Netflix party with friends or take a dog for a walk, spend some time outside. Know that I'm thinking of you and I miss you. Have a wonderful afternoon, evening, day, and I'll see you guys later. Bye.